Continuing on with parametric functions, let's find the rectangular equation when given a parametric equation involving trigonometry. Notice here that our third parameter, our third variable in, is now theta. It doesn't have to be t, and t, of course, doesn't have to be time. Here, we have theta, no problem. Instead of solving for theta and substituting for theta, when I'm given a trig problem, I try to isolate the trigonometric function. That will be our key. We're going to try to isolate the trig function. In our first equation, I can say, well, this means if I subtract 3 from both sides, x minus 3 equals 4 cosine of theta. Therefore, cosine of theta is x minus 3 divided by 4. I can stop there. I don't need to use inverse cosine of both sides to strip this all the way down just to theta. Now, this equation here, I can say, if I add 5 to both sides, I get y plus 5 is equal to 2 sine theta. And if I divide both sides by 2, I get sine of theta is y plus 5 divided by 2. Now what I need is something magical to tie sine and cosine together. I wish I knew an equation. Some have suggested, why don't you use tangent is sine over cosine? I could, but then I've introduced tangent as well, which is be a fourth parameter. But I do know the trigonometric identity, the fundamental one, is sine squared theta plus cosine squared theta equals 1, or vice versa. So if I say cosine squared theta plus sine squared theta equals 1, and then I have to realize this means cosine theta, the whole thing squared, plus sine theta, the whole thing squared equals 1. Well, what is cosine theta? I make my substitution, x minus, it was 3, squared over 4, the whole thing squared, right? When I make that substitution, let me do it correctly. The whole thing will be squared plus whatever sine is equal to squared. Well, we know that's y plus 5 divided by 2. If I square the numerator and square the denominator, using a over b squared is a squared over b squared. That's a rule from algebra. I know that this turns into x minus 3 squared over 4 squared plus y plus 5 squared over 2 squared equals 1. There is my rectangular equation. And of course, we should recognize that that's an ellipse with hk 3, negative 5. So if I wanted to draw a quick sketch of that, I'd go over 3 and down 5. There's my hk. Because a, always bigger, size of the denominator matters with an ellipse. Because our bigger denominator is under the x, I know I have a horizontal orientation. So to find the major axis, I'm going to go left 4 and right 4, and I'm going to go up and down 2. So if I want to draw a rough sketch of that, I could. And of course, from our time with ellipses, we know A is always biggest, so we could find out the distance to each of the focuses by doing b squared plus c squared equals a squared. So not a big deal for us at all. Notice cosine and sine, because of the nature of this identity, is always going to give us an ellipse. And let's just say we substituted this 4 with a 2. So I had the same coefficient. Notice that we'd have a 2 and a 2 squared, which give us 4 and 4. Now, if I had this here, and this, if I multiply both sides by 4, I'd get x minus 3 squared plus y plus 5 squared equals 4 squared. And that would be a circle, of course. So the sine and cosine, if the coefficients out front are different, will give us an ellipse. But if the coefficients out front are the same, we'd have a circle. And notice what this floating number does. The floating number ultimately affects your HK. the coefficients in front of sine and cosine affect a and b respectively, and the floating numbers affect hk, where the center is.